Hi guys, Mr. Roth here, and today we're going to be looking at a trig identity problem that uses a lot of the things we've been talking about lately. Let's dive right in. Cosine of 3 theta. Fortunately, there is no triple angle formula, so we don't have to memorize anything to take this apart, but we can use a little trick and just rewrite 3 theta as 2 theta plus theta. That's going to allow us to use our cosine sum rule. Cosine, cosine, sine, sine, sine. So this becomes cosine of 2 theta, cosine of theta. The sign changes. Sine of 2 theta, sine of theta. Now let's use our double angle formula to substitute something into our double angles. There are multiple forms of the cosine double angle formula. I have an expression here with both cosines and sines, so I'll just use the one that uses both. Cosine squared theta minus sine squared theta. Of course, this is multiplied by cosine. And it's easy to remember the double angle for sine. It's just 2 sine cosine. And let's see, it's multiplied by another sine, so I'll just make this a squared term. Let's go ahead and distribute my cosine over here on the left, giving me a cosine cubed term. That's good. We want one of those in our final answer. And it looks like I have some like terms here that I can combine, right? A sine squared cosine, a -1, -2 of those. So I'm left with cosine cubed theta minus 3 sine squared theta cosine theta. Am I done? Well, unfortunately, I'm not quite done, right? I want an expression with only cosines in it, and here I've still got some sines. So let's now use a Pythagorean identity to put my sine squared term into a to turn my sine squared term into a cosine squared term. Sine squared, we recall, is just 1 minus cosine squared. So let's sub that in. We have still our cosine cubed term minus 3 cosine theta times 1 minus cosine squared theta. Let's distribute this -3 cosine theta into our parentheses. And what do we get? Cosine cubed theta minus 3 cosine theta plus 3 cosine cubed theta. Oh, looks like we're almost done. -3 cosine theta, -3 cosine. I just need to combine my 2 cosine cubed terms, these like terms, to get my final answer. Wasn't that fun? Thanks for listening.